Can you hear me?
Yeah, good evening.
Yeah, good evening, sir.
Good evening. Okay. So let's move on to class. So last class, so we had discussed about what is, right? So what is containerization and what is orchestration tool and what is virtualization, VM deployment and container deployment. Can you put on someone is unmute? Can you put on mute, please? Yeah, thank you. So last class we seen right. What is traditional deployment? What is VM deployment? And so what is containerization? Let me share my screen. What is containerization? And so what is orchestration tool and all? What is orchestration tool? So Kubernetes is an orchestration tool. So with the help of Kubernetes, we, we can deploy your application with microservices. So entire project we can split into multiple models, and so each model we can deploy individually whenever if we need, right? So we can change, we can update, we can change and we can update the particular part and we can deploy it. So already last class we seen. Can you see my screen?
Yes, sir.
Yeah, okay. So now coming to here, so last class, what is Kubernetes? Already we discussed. What is Kubernetes? Kubernetes simply it is nothing but orchestration engine or orchestration tool, and this is also open source platform for managing your containerized application. So if you want to deploy containerization, so that case we go for Kubernetes. So that case we go for Kubernetes. So these are very very important. So if you know DevOps means, so nowadays many people, not and many, so most of the companies they are expecting. So do you know Kubernetes and so Kubernetes architecture and how to deploy your application and so how to create parts and all. Now if we see here, so this already last class we seen right, and so these are the main Kubernetes features. So that is automated so scheduling. So if you want to schedule, see here Kubernetes provide advanced schedule to launch container on the cluster nodes based on their resource requirements and other constraints while not sacrificing availability. So now already you know what is Docker and all. So in Docker, so is there any option so automatically create container and automatically right schedule it. So there is no features in Docker. Already you know right. Docker is just we can create containers and so we can deploy our containers. So as of now, I hope everyone know right what is Docker and how to create containers and all. So this is the Docker. So mostly here what we will do, we can create containers, correct? So we can create containers and we can deploy our applications. Deploy applications. So for example, if application is not working, so it won't create. We need to create manually. It won't take. So automatically it won't take. Docker itself it won't do anything. But so if you come to Kubernetes, this is the automated scheduling. So already last lot we discussed right. So here we are following a master and worker node architecture. Master and worker node architecture. This is the master and so Kubernetes mostly following so master and worker node architecture. So we can maintain many worker nodes. So these are the workers. Just assume these are the workers. So this is the Kubernetes master. This is the Kubernetes master, and so these are the worker nodes. So like this, we can create many worker nodes, or we can node one, and so these are the node two. This is nothing but worker node two. Don't confuse here. Sometimes I am calling a node and sometimes calling worker node. Both are same only. So this is the terminology. First try to understand, try to digest, and so worker node 3. So this is the by default Kubernetes following master and worker node architecture. So this is a master. In each master, it is communicate with our worker nodes. And so if you come to work master, there is many components available. We'll see how it will work and all. So this is a master and worker node architecture. It is following a mainly master and worker node. Now this is the automated scheduling. Scheduling means so without manual intervention, automatically I want to create the cluster, I want to create the container, I want to deploy my application. So this feature not available in Docker. This feature is not available in Docker. Right? So Docker is one part of Kubernetes, but Kubernetes is not fully replacement of Docker. Okay. So this is the initial part, and this is the advanced part. Okay, advanced. So there is many options available, many right features available, many objects available here. So with the help of these objects, we can make your application high availability, and without application downtime, we can deploy your application multiple times in single day. So that is right. So right, this is just right. So this is my repository. So this is my repository, and multiple developers parallelly working, right? So multiple people parallelly working, they are modifying the code. They are modifying the code, and they are daily they are build multiple. They are triggering multiple builds. This is the Docker hub. So here my source code is available, and if any new changes come to, automatically I want to trigger the build. And once build is done, it is generating artifact files, and with the help of that we are creating containers, and we are deploying your application. So in single day without application downtime, if you want to deploy your application, so that case mostly we would go for Kubernetes. Now this is the self-healing capabilities. Kubernetes allows to replaces and reschedule containers when node is die. So now here this is the master, like manager. So these are the worker nodes, like employees resource. So for example, if one node is not working, so this worker node is not working, there is some problem. So there is some problem. So automatically Kubernetes master will take care. It will create one more node. Right, in AWS, right, auto scaling. In AWS, right, auto scaling. Auto scaling is nothing but, right, so based on that specific condition, the based on specific condition, whenever condition it reaches, so automatically I want to create so one more instance. For example, my CPU utilization. If CPU utilization reaches so 60% or 70% or whatever based on your condition. So automatically I want to create one more instance, right? So same configuration, same setup, but here also same. So these are the workers. Right now I have three worker nodes. I have one master. So who is the responsible? Master. Master is the main controller. Master is the main, and master take care these all worker nodes and all. If sometimes right, if this node is not working, if that see here, so schedule container when node dies, it will also kills container and don't respond to user defined health check, and does not advertise them to clients until they are ready to serve. Now this is the problem. Now this node is not working. So my request, I don't want to give this node. I don't want to send my request to this particular worker node. So these two are active. I need to send, right? So same in AWS also, we that is auto scaling load balancer. How your request is distributing. That is right. So that is register instances, deregister, and so drain state. So like this. So if it is not working, your request we are not going to schedule to this worker node. Your request only schedule to this particular worker nodes. So these are the features. Now see here, automated rollout and rollback. So now, so I deployed. So I deployed here. I created one container, Tomcat container, and I deployed my application. This is my Tomcat container. In Docker, we created Tomcat container, and Tomcat container we deployed Java web application, Java web app application. Now, so here I am using specific version. Right? This is the version tags we are maintaining here. In real time, without tag, we are not going to deploy anything. Just assume this is the 1.1. This is the 1.2. This is my version 1.2. Now I created container with the help of this specific version. If this is not working properly, what we will do? What we will do? So already, for example, 1.1 version is working fine. There is no issues. So it is working fine. There is no issues. Everything goes fine. Now this is a new release. I deployed so Java web app 1.2, but unfortunately this version is not working properly. So in Docker, what we will do? Again, we need to update this image and we can create the container, right? But same story here also. But here extra feature. There is rollout and rollback. This is there is one more option is there. Rollout and rollback. Kubernetes rollout changes to application or its configuration while monitoring the application health to ensure does not kill all your instances at the same time. So if so this particular version is not applied, not working properly, we can easily roll out. We can easily roll back also. This is also one of the great feature. Now horizontal scaling and load balancer. Horizontal scaling and load balancer. So suppose, can you hear me? Hello? Hello, can you hear me?
Yes, sir.
Okay. Actually here broadband disconnected. That's what I am asking. So now, okay. Now if we come to here, see, this is the horizontal scaling and load balancing. You know, right? What is horizontal scale? That is nothing but load balancer. So Kubernetes can scale up and scale down the application as per requirement. So now this is a horizontal auto scaling means so this is like so scale up and scale down. So whenever if we need we can increase. Whenever if you don't want we can decrease. So I want to increase, I want to decrease. This is the horizontal. So this is the based on your right requirement. So application as per your requirement. So if you now scale down the application as per requirement with the simple command using the UI user interface automatically based on CPU usage and all. In auto scaling you are maintaining, right? Auto scaling you are maintaining, right? Auto scaling you are maintaining, right? Same way here also. So this is the horizontal auto scaling means so based on that CPU utilization or based on that UI and automatically I want to create one more or whenever if you don't want we can down. So automatically you want to downgrade also. So this is the horizontal scaling and also load balancing. You know, right? Distribute your incoming request to multiple instances. So distribute your incoming request to multiple instances. So these are the main features. These are not only this, there is many features. These are the topmost. So automated scheduling and so this is the hell, you know, right? Self healing capabilities. It is checking self healing means automatically it is replaced by so new node. If any node is die, automatically it is checking and it is replacing and automated rollback and rollout. And if any if something goes wrong, automatically I want to roll back it and so based on CPU utilization that requirement and automatically we need to create instances and so CPU utilization we can scale up and we can scale down. So these are the some of main features and so now see here and service discovery and load balancing. Now if you come to here so Docker, so I created one container, I deployed one application. So how we are accessing here? So directly with the help of that port mapping, right? So with the help of that IP address and we are passing like how we are accessing here. So IP address and we are giving so port mapping, port number, right? Correct. If you go to browser, if you want to access your and slash and context path, application context path. So if you want to access your application, this is the this is the basically we are using. So generally we are following. This is the URL. So IP address, mostly we are using public IP address, your instance public IP address and port number and also application context path. We can access. But if you come to here Kubernetes, so there is a different type services is there. Service means where we want to access your application. So these are the worker nodes, right? Now I deployed my application in this worker node. Just assume this is a Java application. So I deployed my application in this worker node. So here it is running different. This is different node. This is a different node. Now, so here there is a different type services is there. Anyway, we'll see later. There is a cluster IP. Interval also very important. Cluster IP. Second one is node port, and the third one is load balancer, and the fourth one is external. It is English and all. So these are the four types of services available in Kubernetes. Very important. So how many services available in Kubernetes? So cluster IP, node port, load balancer. Mostly we are using so node port and load balancer, and this is the cluster IP. These are the types of services. So we'll discuss later. Just remember there is four types of services. One is cluster IP, node port, load balancer, external name. External name. So external name. So cluster IP means we can access your application only inside the node, inside the cluster, inside the cluster only, inside the cluster. Suppose if you want to access your application outside, I mean to say browser. If you want to access your application browser, so that case we go for node port. If you want to access your application via browser, if you want to access your application via browser, so that case we go for node port. Cluster IP means we can access your application within the cluster only. Very simple. So if you want to access your application within the cluster, we go for cluster IP. Suppose if you want to access your application anywhere, browser, that case we go for node port. And so these are the load balancer. You know AWS how it will work. We'll see later. So mostly we are using node port or load balancer. So anyway, this is one class. I will explain later. So these are the main things. See here, service discovery and load balancer. Here service discovery means this is very so here I have this many, right? This is my master. This is my master, and these are my worker nodes. So these are my worker nodes. So here I deployed many applications. I deployed many applications. So which application? So which application I want to access? Which is my application? How I know? You know, right? So these are the workers. I have just assume we have 10 worker nodes. So this is a master, and these are the worker nodes. This is the node 1, worker node 1, and so worker node 1, and this is the worker node 2. This is the worker node 3. Now each worker nodes, so here 3 worker nodes. Now here I deployed many applications, many applications. Now I want to access my application. How can I identify which is my application? Now got it? So here I deployed so 5 applications. Just assume for your understanding purpose. I deployed 5 applications. So here also I deployed 5 applications. Or here I deployed 10 applications in this worker node. So here also it is running so 5 applications. Now I want to access my application. So how to identify which is my application, where it is running? So how to check it? This is very difficult, right? Real time. We cannot identify. So for identification purpose, here there is one object is there, service object. Here there is one object is there. What is the object name? Service object. We can discover your application with the help of this object. Discover your application. Application. So with the help of this object, what we will do? So this object check your application. Which application you want to access? Which application you want to access? So what it will do? Discover your application. Which object? So which object you want to? So which object? So which application you want to access? Zira. So this is the service object. So anyway, we'll see later. This is the service discovery and load balancing. See here, with the Kubernetes, there is no need to worry about networking and communication because Kubernetes will automatically assign one IP address to the containers and also assign to DNS name. So in Docker, there is one concept is there. Now I don't know whether Docker network is completed or not. So in Docker, so for each container have one IP address, right? Correct? Yes or no? In Docker, each container have one IP address. Correct? Already sir shown many times, right? If you see describe command, if you see describe command, if you see describe command, so each container have one IP address. We are using this command, right? Docker describe or inspect, right? Inspect. If you use Docker inspect or container ID, can inspect or describe? Which command? Docker command. I want to know about more about in my container and all. So there is one command, right?
Docker inspect is correct.
Docker inspect, and we are giving so container ID. So if you use container ID, what is the container IP and what is how much resource? There is we can see lot of information. And same way, if we come to Kubernetes, so here also see here. So for networking and communication, so here I have multiple containers I am going to create, right? So here also Docker is there, here also Docker is there, here also Docker is there. Now how these are connecting each other? By default, Kubernetes itself, it is by default, all are connecting each other. All are connecting each other. You don't worry. But each container have one IP address. Each here mainly here pod is there. This is the pod. This is the pod. Pod is nothing but a smallest runtime instance, and the pod is the taking care your container. Pod is running. So inside the pod, containers are running. So that is the hierarchy, it will work. But each pod has one IP address, and with the help of all are connecting each other. Now there is the storage orchestration. Storage is nothing but data. I want to store some information. So if you want to store some information and all, and so in Docker also there is one concept is that Docker volume concept. So anyway, here also we can know more something. So Docker volume, and if you want to store some piece of information, so Docker volume concept. Okay, so it will store some information whatever if we have any some information I want to store some piece of information. So that case so here also we can use see Kubernetes, you mount the storage system of your choice. You can either app or local storage whatever it may be, and there is a public cloud or such as GCP or AWS or any other cloud. If you want to connect, we can connect also, and we can store some information. So these are the high level features only. Apart from this, so we are going to discuss a lot of features. Clear, guys? So these are the automated scaling and self healing and automated rollout and rollback and horizontal scaling and also load balancing and service discovery and storage part. These are the basic. These are the main right high level points. See here, Kubernetes provides advanced scheduler to launch container on your cluster nodes. Self-healing means rescheduling, replacing, and restarting the containers which are died. Suppose one container is not working. What it will do? Automatically it will create one more container. You don't worry. That is the self-healing capabilities. Self-healing capability means Kubernetes itself, it is taking care. You don't worry. In Docker, we need to create manually. But if you come to Kubernetes, no need to take care anything. So with the help of some right script, we are automating everything. If any pod is not working, so automatically it will recreate and automated rollout. If something goes wrong, I want to roll back it. And horizontal. See, Kubernetes can scale up and scale down applications. Suppose if you want to, how many containers you want to run by default. So in Docker by default it is creating only one container. But if we come to Kubernetes, at a time how many containers you want to create? So that and all we are setting. There is one tag is there, replica set. Replica, replicas means how many parts, how many containers you want to maintain. If I mentioning five means, so by default it will create five parts and five containers. In each part contain one container. Each part contain one container. So these are the high level. Anyone, any doubt as of now? Clear, guys? Hello? Got it?
Yes, sir.
Okay. Now let's see here. What is Kubernetes architecture? This is very, very, very important. In the interview also, many people asking this question. Can you explain Kubernetes architecture? And so they are asking like, so what are the main components in Kubernetes? Can you explain? So they are asking like this. This type of questions mostly they are asking here. So Kubernetes architecture. Now, if you come to Kubernetes architecture, and these are the already you know, right? This is the Kubernetes master. This is the master server. Don't confuse here. This is also one server. This is also one server. This is also one server. But manager also resource. You also resource. But only role is different, right? All are all are employees only organization. But each employee have some roles, right? So, but these are the master is the main role, like manager. He is the responsible for taking your control all your worker nodes. So now see here, this is a worker node. This is one more worker node. Like this, we can create many worker nodes. And this is the APIs. This is the Kubernetes master. And these are the user interface. Now, if you observe here, so this is the Kubernetes architecture. And these are the user interface. There is two ways we can connect via UI level, via CLI level. Now, if you come to here, so this is the master, right? So this is the master. Now this is the master and this is the worker nodes. Just assume you have only two worker nodes. And so this is the user interface. So this is the user interface. User interface means UI. So we can connect via so UI level or via you can connect via this is the Kubernetes master. This is very, very important if you understand nothing. So here we have API server. How many components? So API server. Next, so etcd. Next, controller and scheduler. So these are the main components. This is the UI level. So we can connect UI, that is the user interface, or we can connect via command lines. Command line. So this is the user interface. So we can connect anyway. That is your wish, up to you. So this is the UI, user interface. User interface. And this is the CLI. So that is nothing but this is the so kubectl command line interface. This is nothing but CLI. So CLI command line interface. So now just assume I am the end user. I am the end user. End user means customers, right? I am the end user. Now I send one request. I am the end user, customer. So if you send any request, the first request go to API server. So in master there is four components. That makes these are the four components. API server, scheduler, controller manager, etcd. Just try to understand. So we need to buy heart. If you understand, no problem. If you not understand, you need to buy heart it. So what are the main components in master? Four components: API server, scheduler, control manager, and etcd. And so there is two ways we can connect our master. How many ways we can connect? Two ways. Whether we can connect user interface or whether we can connect so CLI command line interface. So command line means right. So like git bash. So this is nothing but command line. Right. If you open any git bash and all, so this is a command line. So this is the command line git bash. So this is CLI. Simply, if you want to understand, this is the CLI command line interface. If you connect any GUI, that is a user interface. Now, if you come to four components, so what is API server? For example, I enter my username password. So the first request go to API server. Who will receive your request? API server. Suppose if you go to any office, so there is a front desk is there, right? What they will do? First, they will receive your request. What do you want? Where you want to go? What I really need? Correct? Same way. So this is the API server, like front desk. So if we send any request, a user send any request, the request go to first API server. Who will receive your request? API server. Application program interface. This is the server. API server. So the request it will go to API server. API server read your request No, right? So now they are asking. So they are maintaining one, right, notebook. So what purpose, which date, which time, whom do you want to meet? Okay, so phone number. They are asking some information, right? Same way, API server receives your request, and this information it will store into the etcd. It will store into the etcd key and value format. How it will store? Key and value format. So like this. So the API etcd is nothing but it will store data into the key and value format. Key and value format. Value. So here key is nothing but, for example, so this is the user name. This is the key. Name equal to, for example, ABC. This is the value. Correct? For example, password. This is the key. Actual value. This is the value. Actual value. This is the value. This is the value. So first, so if we send any request, first the request go to whom? API server. API server read your request, and that information and all it will store into the etcd. In which format? Key and value format. Key and value format. So this is the first step. Now see here. So what is API server? The Cube API server interface with API. It is a front end of the Kubernetes control plane. This is nothing but front end and communicate center for developers and system administrators and other Kubernetes components. Which component you want to interact? Whatever you want. Meeting lo అని చెప్పు. నాకు అవసరం. So whatever you want. So who will this? So first the request receives API server, and API server receives your request, and API server, this is the front end, receives your request, and communication center for developers and system administrators or anyone who are maybe. So now I send one request. Maybe it is CLI way, or whether I can select user interface. Now the request go to API server. Now see here communication. Now what is etcd? Etcd is a simple distributed key value stores. So this is the key and value storage. This is like nothing but storage. So etcd is the simple distribute key and value store. Kubernetes uses etcd as its database. So how the Kubernetes maintaining etcd? Like database. How they are maintaining record, right? If anyone reach office, so they are entering full information: name, time, date, what purpose, whom do you want to meet. So every information they are they are maintaining that record, that notebook, right? Same way, this is nothing but simple data storage database. This is nothing but simple database, and entire your information that API server read, API server write in the etcd form, key and value format, and some of data stored in the etcd job scheduling also. So whatever it may be, the entire information it is stored into the etcd only. This is nothing but a simple database, and it is maintaining a key and value format. Now clear? Anyone any doubt here? So what is API server? API server is nothing but a front end controller. Suppose if you send any request, who will receive first your request? API server. API server read your request, and that information and all where it is writing etcd. So that is the simple data storage, and it is store, it is maintaining entire information with key and value format. Key and value format. Now anyone any doubt here? API server and etcd. Clear guys? Hello.
Clear, sir.
Yeah, clear.
Okay. Now let's come to one more controller. Next, etcd, so this is the key and value format. We can store entire information, and so API service the front desk like a receiver, receive your information, and so there is a scheduler. See here, scheduler watches the pods and assign the pod to run the specific node. So now if you come to here, so these are the main four components. If you come to worker node, here there is four components: pod, Docker, kubelet, kubeproxy. So every worker node has four components, main components. What are those? Pod, Docker, kubelet, queue proxy. Just remember. So we'll discuss later. So now scheduler, what it will do? The scheduler schedule your application, which pod you want to deploy. Now see, observe here. Scheduler watches the pod. So the scheduler keep on watches our pods. So here we are maintaining multiple worker nodes. So here we are maintaining multiple worker nodes. What scheduler will do? Scheduler keep on watches your pods and it is assign the pods to run specific host where we want to create. For example, I want to create one pod. So this is the one worker node, this is the one worker node, or maybe one more worker node. So which is ideal, which is there is no work, which is no work, no burden. So it is scheduled to the particular worker node. So that is the meaning here. See here, scheduler watches the pods. It is keep on watches the pods and assign the pods to run on specific host. Which host mission, which worker node we want to execute. That is the scheduler. Scheduler main duty is keep on watching pods. Pod is nothing but, we'll see later, pod is nothing but smallest building block unit to run your application. Very simple. So we'll discuss later. Anyway, that is also here is there. So what is pod and all? So pod is nothing but, see, a pod always run on the node only. A pod is the smallest building block of basic unit of scheduling your Kubernetes. And each pod has one unique IP address. We'll see later. So for the time being, just remember. So this is the scheduler. This is the main duty. So scheduler means watches the pods and assign the pods to run which host mission where you want to execute our pod. That's it. Now there is a controller. Now one more component is there. This is the controller. So controller means, right, name itself we can understand. Controller, control. So it will control all your worker nodes, whatever you want. Now observe here. So controller manager runs the controller in background, which runs on different tasks in Kubernetes cluster to perform the cluster level functions. That is nothing but replicas, keeping track of worker node information, handling node failures and all. So it is control. It is checking. So which worker node not working properly, which is not working, and so it is die, and what are which part where it is running. So the entire information it is checking. 1 second. This done. Okay. Can you hear me? Now can this broadband disconnected? No, automatically. I hope you can hear, right? Hello?
Yes, yes,
Okay.
yes, yes.
Now, okay,
Yes,
okay,
yes.
okay, okay. Now see here. Now if you come to controller manager, there is many controllers in Kubernetes cluster. Many controllers. One is node controller, replication controller, endpoint controller, replica set controllers, deployment controller, demand set controller, job controller. For each object, we have one controllers. Now see here, node controller. This is a node, right? This is a node. This is worker node or node, both are same. Don't confuse here. So worker node or node, both are same only. Sometimes I am also calling node. Sometimes I am calling worker node. Both are same only. Now if you come to here, node controller, it is responsible for noticing and responding when node go down. So it is checking. So which node is goes down, which node is problem, which node is not working properly. So it is keep on checking. It is controlling the worker nodes only. Now replication controller. Replication controller main purpose is monitoring your pods, life cycle of your pods. Simply if you want to understand means this is the pod, right? So it is maintaining a pod life cycle. It is maintaining pod life cycle. That is replication controller. See here, it maintains the number of pods. How many pods you want? For example, here I given 5 pods. So I need 5 pods. That is replicas. So your replicas. I given so 4 pods. So by mistake, unfortunately, one pod is deleted. So automatically it will create one more pod. So that this part and all taking care by replication controller. See here, it maintains the number of pods. How many pods you want to maintain, and it control how many identical copies of the pod scheduling be
Sir,
run
your voice is
somewhere.
breaking, sir.
Voice is breaking. Okay, wait. Just wait. I will connect. New connect. 1 second, I will change broadband. I'll change it. So now can you hear me? Hello, వినిపిస్తుందా? Hmm. Hello, can you hear me?
Yes, sir.
Okay. So if you have any challenges, please let me know. So based on this, we'll plan it. Okay. So actually, so the broadband disconnected, we connected different network. So if voice breaking or video is lagging, please let me know. Okay. Now this is the replication controller. So node controller means it is mostly taken care by nodes. Whether node is working properly or not, node goes down or is there any problem. So that and all taken care by node controller. And replication controller. Replication controller, it maintains the number of parts. If it control how many identical copies of parts should be running somewhere on the cluster, how many parts and all, it is taken care by replication controller. Now there is endpoint controller joins services and parts together. So the endpoint controller mostly service object already I discussed, right? Service is nothing but endpoint. So service is nothing but endpoint. Endpoint controller mostly it will check with the services and parts together. So which one we want to identify? So that one all. Next, replica set. Replica set ensures number of replication of the parts running at all time. So this is both are same only replication control and replica set. How many parts we want to maintain at a time? How many parts we want to maintain at a time? So this and all taking care by replication controller and replication set also. And there is a one more topmost object in Kubernetes, deployment object. This is the deployment controller. So it provides declarative updates for parts and replica set. Whatever you want to update. So this is the main. So deployment controller is the provides declarative updates. I want to update something. Now you created pod. Now I want to update something. So from with the help of we can update deployment controller and parts, replica set. How many? So this is the main object in Kubernetes. There is a daemon set object, copy of the specific pod. So right. So this is the worker node 1. This is the worker node 2. Now, so for each worker node, I want to maintain one copy. That is a common functionality purpose. So if you want to monitoring, if you want to check some of common functionality. Now see here, this is my worker node. This is the worker node 2. And each worker node, I want to maintain one copy. Not only 2. For example, I have 10 worker nodes. In each 10 worker nodes, I want to maintain one single copy. So that case we go for this is one controller is there. So what is that controller name? So daemon set. Daemon set controller ensures make sure that all nodes run one copy of specific pods. So each worker node it is maintaining one pod. Which pod? Daemon set pod. Daemon set object. So this is each worker node. Each worker node it is maintaining one copy. Now there is a one more is there job scheduler. Job scheduler is nothing but this is a supervisor process for parts carrying out the batch jobs. So which one you want to execute batch wise? So there is one more. This is also one job process controller, and this process controller the main thing is so batch jobs. Right? Batch jobs means so multiple we need to run at a time. So multiple tasks we need to execute at a time. So that case we go for job controllers and all. So these are the main components in master. I hope now you got it. What is API server? and what is the etcd, what is the scheduler, what is the controller. So if you come to controller, not only single controller, many controller is there. So node controller, replica set controller, replication, and also right, a demand set controller, deployment controller, and endpoint controller. So these are the different kinds of controllers, but each controller taking care by specific part. So node control, it will take care nodes only. So replication controller and replica set, it will take care only parts. And deployment object is mostly it will take care update and replica set and all. Daemon set, it is maintaining the single copy in all worker nodes. And also endpoint, it is maintaining the service. Control the joint services and parts together. How it is these parts are connecting to a particular service and all. So these are the different kinds of controllers. So anyone any doubt here? So now I hope you got it right. So what is API server? What is scheduler? What is control manager? What is etcd? So these are the main components in master. And same way, if you come to worker node, and each worker node have these are the main components. What are those? Pod, Docker, kubelet, kubeproxy. So what is this? Docker, pod. Docker is the common in all worker nodes. So without Docker, there is no Kubernetes. So Docker is mandatory each worker node. Without Docker, it won't work. We cannot work. Okay. So this is the pod, Docker, kubelet, kubeproxy. Now we'll see what is kubelet and what is kubeproxy and what is pod, what is Docker. So Docker and all already you know. No need to discuss again. Now if you come to here kubelet. Kubelet is nothing but this is right. So right. This is the agent right. For example, if you want to apply any, if you want to open any LIC or anything, agent is nothing but mediator. Simply if you want to understand, kubelet is nothing but agent. See here, kubelet is the primary node agent run on each worker node and reads the container manifest file, and which ensures that containers are running healthy or not, it will check it. So that is the main duty of kubelet. In interview also many people so they ask this question, what is kubelet? Kubelet is nothing but this is the primary node agent. So this is the primary node agent, and this kubelet running on each worker node. It is running on each worker node, and what it will do, it reads the container manifest file. It reads the container manifest file, and it makes sure that it will check, it is checking so whether that container is running or healthy or not healthy. So that is the main role of kubelet. I hope now got it right. So what agent will do? Agent will call multiple times. So these are the features. Did you apply or did you finish? So they are every right. They are tracking. They are checking. Same way, kubelet also. This is the primary node agent. It runs on each worker node. So what is the main role? So it is mainly it will so read the container manifest file. It read the mainly container manifest file, whether this container is healthy or whether this container is any problem. That is, it is checking health check, and it makes sure that the containers are running in pod. The main thing is, so each container running in pod or not. And kubelet does not manage containers which were not created by Kubernetes. So and kubelet doesn't right does not manage containers. It won't maintain containers which are created by the Kubernetes. Only which are we created by, so that and only it is taking care by kubelet. Now there is one more thing is there, kubeproxy. Right, kubeproxy. This is one more component in worker node. So this is total related to network. Total related to network. See here, kubeproxy enables the Kubernetes services abstraction by maintaining the network rules on the host and performing connection forwarding between all your worker nodes and pods. This is total related to network only communication. How this pod is, how this worker node connecting this worker node, how this pod is connecting to this pod, how this pod is connecting to this pod. So this and all taking care by who? Kubeproxy. You don't worry. So by default, one network available in Kubernetes. So with the help of all pods are connecting each other, and also each pod has one IP address. So This part three containers. This part only one container. This part two containers. So single. So we can, that is based on requirement, we can create multi containers also. Single container part. This is the multi container part. This is the naming convention. So if only one container is running in pod, that is nothing but single pod, single container pod. Suppose if multiple containers running, multi container pod. So then this is nothing but sidecar also. Sometimes we are calling. So somewhere we can see that one also, sidecar. Now this is the kube proxy. See here, observe here kube proxy. So this is the rules of performing connection forwarding between your pods and all. Next, kube proxy maintains network rules and nodes. So this is the set of rules. So kube proxy is a set of rules. This is the network rules and how these pods are these worker nodes connecting. The network rules allow network communication your pods from inside or outside your cluster. So this the main role of this kube proxy means, and so communication your pods inside or outside the cluster, inside or outside the cluster, within the Kubernetes or outside the Kubernetes also. And also it helps to have network proxy and load balancer also it is maintaining. See here, right, load balancer connecting multiple instance, distribute your incoming request to multiple instances or multiple servers. And also service is just like logical concept. This and a logical concept directly we cannot see, right? And so this is configured by kube proxy pod that is running on the each worker node. So that kube proxy is running on each worker node. So now if you see this image, we can easily understand. Now we know this is the primary node agent. So this is the primary node agent. This is the communication between your pods and nodes. Communication between your pods. This is total communication. This is the network. So this is total taking care by network only. Communication. How this pod is connecting this pod. How this pod is connecting this pod. How this pod is connecting this pod. This is taking care by kube proxy only. You don't worry. Now, so there is, these are the main role of kube proxy. Now there is a container runtime also is there. Container runtime. So each node must have container runtime such as Docker, RKT, another container. Right, Docker daemon. So if you come to Docker architecture, so what are the main components in Docker architecture? Anyone? What are the main components in Docker architecture? Docker daemon, right? Docker client, Docker daemon, image.
Dark registry.
So this is the client, Docker client, correct? So wait, this is the Docker client, and this is the Docker daemon. One part is Docker daemon, correct? DAE or
Yes.
DEA? Daemon, DEA,
DAEMON.
DAE, DAEMON, Docker daemon. Next, what are the main components? Registry,
Images components.
images, containers. Next, already sir explained, right? So these are the main, correct? So client, so this is the Docker client. If you send any request, the request go to Docker daemon. Docker daemon knows so which one you want to connect with, which one you want to call. So based on this, so it will work. So leave it that one. This is the Docker hierarchy. Same way. So this is the container runtime. Container runtime means here we are using one container runtime. So which one we are using container runtime? Docker. So here mostly we are using which one? Docker. Already you know, right? So that is the reason. So mostly we are installing Docker only. So mostly we are installing Docker. This is the daemon. So it will take care everything. You don't worry. Now, so these are, now if you come to here a pod. So this is the pod. Now last one is pod. So pod always run on master or worker node. Pod always running on worker node. Pod always running on worker node. One or two people they ask this question. So where pods are running? Master or worker node? Pods always running on only
Worker node.
worker nodes, not in master. Worker nodes only. Just to make sure that, so pods always running on worker node only. Next pod is what is pod? Just I will finish 5 minutes this one. So what is pod? So now you know, right? You know containers and all. Now here the new terminology is pod. Pod is nothing but this is the smallest building block or basic unit of scheduling in Kubernetes. In Kubernetes cluster, a pod represents running process. So here pod represents running process. Pod represents running process. Smallest building block or smallest unit to run your application. That's it. Now inside pod, you can have one or more containers. Now already we are seen, right? So here we can one or more containers in each pod. So maybe one container or maybe multiple containers. That is based on your requirement. That is based on your requirement. That is based on your requirement. See here inside pod, inside pod, you can have one or more containers. So those containers all share unique IP address, unique network IP, unique storage, network, and any other specific application to the pod. Application to the pod. Application to the pod. Next, pod is a group of one or more containers which will be running on the same node, some node, and pod abstract network and storage away from the so underlying containers. So these are the one layer, and with the help of let me increase. So like this. Now see here. So these are the versions, and this is the manifest file. So anyway, next class I will show you how it will work and all. So now see here, each pod has some resource. Each pod has some resource. So what resources? Each pod has unique IP address and unique network IP, and each pod has some storage volume, and each pod has some specific, right, specific resources and all. That and all used by containers only. So containers are running on where? Containers are running where? Inside pod or outside pod?
Inside.
Inside pod. Inside pod. For example, this pod has 4 GB RAM. So these three containers used by this 4 GB RAM. For example, this pod has a 1 GB memory. Sorry, 1 GB space. So this all three containers can use that 1 GB storage. So that is the main purpose. So now see here. Now pod is group of one or more containers. Now pod is abstract layer underlying the container. And so let's you move containers around the cluster move easily. If you want to, we can move clusters one pod to another pod also. And each pod, this is important. Each pod has unique IP address. IP address within the cluster. Now, so this is the cluster, right? So that is the one cluster. Inside the cluster, we can create multiple pods, and each pod has one unique IP address. Any data saved in the pod will disappear without persistent storage. This is the volume concept, storage, saving data. So saving data. So if you see here, suppose if you save any data, if you save any data in our container or in our pod, so that and all, so without persistent storage, we cannot save it. We cannot save it. So that is the, these are the main points. So what is pod? Pods always running on worker nodes, and pod has unique IP addresses and some storage, some other resources. These resources used by containers only. Next, what is this? Next, if you save and abstract layer and more. Now each pod. So maybe pod contains single container, or pods may contain multiple containers. So that is nothing but, so that is based on your requirement. Now if you come to here, so this is the manifest file. So if you want to create any pod, if you want to create any pod, this is the manifest file. So this is the API version, kind equal to metadata, name, labels, spec specification. This is the container part. This is the container part. So anyway, next class I will explain all these things, how it will work and all, so we can understand. So clear guys? I hope you got some idea, right? What is Kubernetes architecture? Very, very important. So if you understand this flow and all, we can easily understand coming classes. Suppose if you don't know what is pod, suppose if you don't know what is kubelet, suppose if you don't know what is a scheduler, Suppose if you don't know, so there is blank. Hey, what it will do? So there I'm saying pod. First you need to know, right? What is pod? Inside pod, what is it contain? And what is kubelet? This is a node agent, primary node agent, and it is checking container health check whether my containers are running properly or not. Do we have any issues or not? And what is kube proxy? This is total related to network communication. So how this pod is connecting other pod, how the pod 2 is connecting pod 3, how pod 3 is connecting pod 1. So this and all taking care by kube proxy only. And kubelet main purpose is checking monitoring whom containers. So whether this container is healthy or not. This is the primary node agent. So it is keep on checking containers whether it is healthy or unhealthy. So these are the main components. So what are those? Kubelet, kube proxy, pod, and Docker. And if we come to master, so API server, scheduler, controller manager, etc. So these are the main components. Clear? Anyone any doubt? Yes or no?
No.
So I hope now got it right. So next class, so we'll see. So how to set up so Kubernetes cluster and all, and so what is pod? I will show you practically how it will work. Okay. So that's it from my side today. So if you have any doubt, we can ask, or else we'll wind up. We'll connect tomorrow.